Chapter 6. Some suggestions and a glimpse of an electric farm of the future. The simplest and cheapest method of getting electricity into the soil and to the roots of plants is by the use of some form of Geomagnetopher. In using this device, we must be careful to arrange it so that the atmospheric electricity will come down the wire on the pole to the system of wires in the soil, and not down the pole itself to the earth immediately surrounding it. The pole may be made a non-conductor by being coated with resin, or it may be set into a non-conducting substance. As to the height of the pole, it should reach far above the surrounding trees or other high objects, or better, the pole should be situated on elevated plots of ground. We must learn more about the relation of the area of soil beneficially affected to the height of the pole. We must also try to find out more about the nature of the soils most responsive to the application of electricity, as well as the variety of plants most susceptible to its influence. After the installation of a Geomagnetopher, the main cost will come from the replacing of the distributing wires in the ground, which wires are subject to corrosion. The use of earth batteries seems to be a more reliable method of furnishing electricity to the soil. For the successful use, the soil should be kept fairly moist, especially around the metallic plates. The use of weak acids in the vicinity of the zinc plates may be an advantage. If of any disadvantage, it would be that they consume the zinc too rapidly, thus increasing the expense, possibly without a corresponding increase in the good done to the crop. The plates should be of ample size, and their distance apart should be regulated to suit the crops planted between them. The greater the distance, the larger the resistance to the current and the less its strength. When a current of but little strength is wanted by soils or plants sensitive to it, rows of zinc plates should be connected with rows of copper plates at considerable distances from each other. If stronger currents are needed, the distance should be diminished. A sensitive galvanometer inserted in the wire above the ground will be of assistance in finding out the strength of a current best suited to the circumstances of soil and crop. It will surely tell us whether or not a current is flowing through the soil. This will point out the cause of occasional failures in this form of experimentation. The action of the battery will slowly destroy the zinc, while the copper will last almost indefinitely. So it will be best to raise the zinc plates from the soil when no crop is being grown, or at least to disconnect the wires which join the zinc and copper plates. Iron can be used instead of the more expensive zinc, but the current furnished by the iron and copper battery is almost too weak to be of any service. The advantages of this method over that in which the Geomagnetopher is used are the absence of underground wires which corrode and have to be replaced in time, and the power to furnish a more constant supply of current. The one disadvantage is the interference the plates and wires offer to cultivation. The earth batteries would seem to be more useful in raising berries and vegetables in greenhouses or small plots, and the Geomagnetopher in growing potatoes or cereals in fields. When electricity can be generated cheaply enough by dynamos or other means, its application in soils in which crops are growing can be regulated to suit every condition. Each soil and crop will get its dose as exactly as effectively as the physician prescribes tonics and nutrients, possibly more so. In using the arc light, the main thing to be considered are the proximity of the plants to it, the nature and color of the shade interposed between the plants, and length of time the plants are exposed to its rays, and the hours of the day or night most suitable for its use. If the arc light is too near the plant, though not near enough to affect it by its heat, it may nevertheless scorch its leaves and cause serious damage. The ultraviolet rays are said to be responsible for this, as they, according to Professor Rowley, produce great activity in the protoplasmic contents of the cells, particularly of the palisade tissue, or hasten the physiological process. This activity calls at once for large supplies of water, and it is drawn first from the overlying epidermal cells. These cells, being emptied of their contents, collapse like an empty grain bag. In other words, the vital activity is hastened so much by the naked light that the plant cannot supply materials quickly enough, and it is forced to death. Plain glass will strain out these dangerous ultraviolet rays sufficiently to prevent this damage, or it may be avoided by removing the lamp to a sufficient distance from the plants. Experiments are being conducted which may determine for us what colors of lampshades are most desirable for use in cultivating the various plants which are benefited by the arc light. Experiments have been made with the spectrum of the sun to find out which of its rays are efficacious in causing the formation of woody fiber, which in the formation of starch, which in the formation of chlorophyll, etc. But the results have not been conclusive on account of the difficulty of maintaining the spectrum steadily at the same place, and on account of the short periods of time it could depend upon for action. But with the arc light, the spectrum can be furnished continuously, and into different colors kept under a number of similar plants as long as desired. Thus we may learn which colors are best suited to the varying needs of plants at the different stages of their growth. Here again, we may meet the questions of dosage, and may prescribe certain rays for early life, others for adult, or combinations for especially developing the starchy, saccharine, woody, or other substances in the plants. Or we may hasten or retard the ripening of crops to suit the varying conditions of the market. While it is stated by careful investigators that plants do not seem to need rest at night, yet further study of them under the influence of an electric light may put us in possession of facts which will enable us to give them their light stimulus at the proper times and for the exact length of time, in addition to giving it of the right strength and color. The fact that diastase, which transforms starch into sugar, acts best in the absence of light, seems to argue that the leaves of plants which make starch in the presence of light should have periods of darkness to permit this transformation to go on satisfactorily. Otherwise, the leaves may become choked with starch, and the plant, although it has an abundance of starchy food, suffer because it cannot utilize it in the presence of continuous light. But observers warn us not to give the light too freely at noonday, or when the heat is greatest, and others suggest that alternations in the dosage are of value. We have before made mention of the effects of heliotropism. When one thinks of the combinations which can be made of the methods of furnishing electricity to the soil and to plants with the methods of furnishing electric light to the leaves of plants, he feels how little indeed has been accomplished, and sees ahead work for years of experimentation. And then there is the possibility that plants in future generations may become accustomed to being partly fed by the electric light and partly by currents in the soil, and may adapt themselves to the new conditions to the increased profits of the horticulturist. While the vast majority of the experimenters have reported results highly favorable in electro-horticulture, yet, as we have before pointed out, there have been a few who did not obtain the good results so enthusiastically heralded by others. It may be that in some localities of the Earth's surface, certain conditions obtain which render such places more favorable ones for such experimentation than others. Experiments with earth batteries may fail on account of the connecting wires, above ground being twisted around the projecting plates instead of being soldered to them. In dealing with such feeble currents, no more resistance should be opposed to them than is absolutely necessary, and then the soil may be unsuitable for sufficient chemical action upon the zinc plates, possibly too scanty in proper mineral matter, or too dry, and hence unable to generate a useful current. It is always well to test the strength of the battery, and still more important to see if there is any current flowing, by means of a sensitive galvanometer inserted in the wires connecting the plates. The practical farmer will want to know if electric farming will increase his profits before he thinks seriously of adopting it. He may agree that it will be more scientific, perhaps more interesting, and likely less laborious, but will it pay? It is too early to give satisfactory figures concerning the results of the application of electricity to the growing of plants and vegetables, as experiments have not yet been made on a sufficiently large scale to furnish reliable statistics. But the smaller experimenters seem much encouraged, and some of them are now engaging in electro-horticulture much more extensively. As regards the use of electricity as a mode of power on the farm, the experiments have reached the stage where figures can be safely given in the favor. Recently, Julius Muth, United States consul in Mecklenburg, Germany, gives some interesting figures concerning a farm near that place run entirely by electricity. The dynamo furnishing the current is driven by a turbine whose power is furnished by a small brook, and the electricity is stored up in an accumulator of 66 large cells. The yearly expense of running the farm under this old system is $1,713.60, while under the electric system they were reduced to $1,492. Although it was not our intention to consider the application of electricity to the machinery of farms in this little book, yet we give room to a statement of Otto Döderling, United States consul at Leipzig, in his report to the Department of State in 1895 concerning the electric plow in Germany. He says, after giving elaborate figures, it is thus evident that the working expense of the electric plow for extensive husbandry amount to less than half of those incurred in working the steam plow. This contrast is readily explained. For one, the capital sunk in plant is only 1/3 of that required for the steam plow. Two, the expenses connected with the generating of power are materially lower than is the case with the steam plow, in which a very considerable surplus power has to be raised in order to work the pulleys and brakes and to overcome the stiffness of the rope. Three, the extensive transport of water is herein entirely done away with. His reference is to the electric tilting plow made by Messrs. Zimmerman and Co. He also adds, I have been informed by the director of the Hale factory that electricity will shortly also be used in digging out potatoes and sugar beets. When electricity can be furnished more cheaply than at present, what may not a combination of electric farm machinery, electric culture of the soil, and electric stimulation of plant life mean to the farm? The following extract from a lecture delivered by the writer some years ago at a farmer encampment is appended. Thinking a little electric speculation may interest some of the readers. The farmer we see in the future has no need of horses. Occasionally, he may be found with a pair of spirited animals with which to vary the monotony of riding in his speedy electric carriage. His work is done by electricity furnished by some nearby waterfall, or by a combination of wind engine and storage battery, or by some company which manufactures electricity cheaply and sells it to communities of farmers. His produce is sent to the nearest shipping station by means of electric railways on the highways, which run alike winter and summer, and which, when once put down, require no filling up of chuck holes and no plowing up of the sides of the roadways and throwing of the dirt into the center. Scattered over his farm are numerous poles carrying insulated wires. Let us go out to his wheat field and see what he is doing. It is the time of harvest. We see an odd-looking reaper and binder from it. As it moves rapidly along, there pays out some insulated wire which connects the reaper with the wire coming to the field from the highway, through which wire it receives the energy which runs it. Thus the farmer with great rapidity cuts, binds, and shocks his wheat. He does the work alone and complains not of weariness, but only of a sense of loneliness. As he stops his machine for a few moments to shift the wire, he tells us that this method is getting too slow for him on account of the reeling and unreeling of the wire, and that he is thinking of buying the latest patent which carries its own electric supply and storage batteries, only he fears that the recent experiments looking towards making electricity directly from coal are so near to success that this new machine in turn will soon become old-fashioned. After he is done, a wagon comes out, moved by the same mysterious force, and gathering the sheaves takes them to the barn. In course of time, an electric thresher, which cannot set the barn on fire from red-hot cinders, separates and cleans the wheat, and soon the electric railway transports it to the market. His electric plow is quite an improvement on the one which not long ago turned up the first furrow in American soil at the Kansas sorghum experiment station, and his electric harrow pulverizes the ground to an evenness that is marvelous. Among the many lesser inventions of which he makes use, we notice a simple device to protect some favorite trees from the invasion of caterpillars. The trunks of the trees have two narrow bands of copper around them, at short distances apart. These bands are connected by wires with the poles of a battery capable of delivering a very strong current. When a caterpillar crawls up one of these trees and crosses the metallic bands, it is in the same unpleasant situation as the murderer in the electrocution chair at Sing Sing. Its body makes the connection between the terminals of the battery, and it goes no further. If the current is powerful enough, a diminutive arc light is the result, and a cinder all that is left of the caterpillar. Indeed, he is tempted to use this method with some modifications in dealing with the chicken thieves, the burglar, and even the ubiquitous tramp. See the huge earth batteries and tall geomagnetophers he uses in forcing his crops, how he spreads electricity as it were through the soil, and keeps large arc lamps burning at night to still further assist in hastening the growth of his farm products. With the heat generated by these lamps, or by means of special resistant coils, generating it more abundantly, he is able to prevent frost doing damage to his earlier and more tender fruits and vegetables. Had the late rain-producing experiments been successful, he might even picture this fortunate farmer calling down the refreshing showers whenever he thought the crops needed them. And if he believed with Jean-Paul Richter that the thunderstorm bath was as refreshing and invigorating to the human system as to the trees and flowers, he would invoke the storm with his bombs when he thought that his grain needed rain. Regardless of the fact that there was a picnic in the wood of a farmer encampment in the grove, indeed he would take out his wife and children and form a rain party and be invigorated and strengthened by the wonder-working arm of the thundercloud. Our electric farmer, besides using electricity to assist in maturing his crops, has learned how to apply it to the destruction of one of his greatest enemies, weeds. With a dynamo furnishing a current stepping up from 2,000 to 24,000 volts as needed, He sends the current through the weeds by means of brushing a fine wire passing among their tops as his generator moves over the field. The other pole of the circuit being connected with the ground through the wheels of the machine carrying the dynamo. This strong current breaks up the cellular tissues of the weeds and thus destroys them, just as, on the larger scale, a stroke of lightning destroys the tree. In picturing the electric farm, one has a very large range of probabilities to draw upon, but there is ever the danger of letting his fancy run riot and of making the electric farm of the future appear very utopia. There will ever be plenty of hard work for the farmer, even on the model electric farm, but he will have more pleasure and satisfaction in his work, and it is to be hoped more profit from it.